Hello everyone, I am Smita and I am a student of Namchi Government College, South Sikkim, Physics Honours 4th Sem. And in this video, we will be discussing about Doppler effect, which was given to me as an assignment for our sessional, and I have prepared this video under the guidance of our respected sir, Dr. C.P Khatiwara. So let's start our learning. First of all, I would like to explain you what is Doppler effect. Doppler effect is the apparent change in the frequency of sound heard by an observer due to relative motion and between the source and the observer. Moving next to the history part, how this name had first came, it was named after the scientist Christian Doppler, who first came up with the idea in 1842. He learned that sound waves would have a higher frequency if the source was moving towards the observer, and it will have lower frequency if the source was moving away from the observer. Now, as we all know, the general equation of the Doppler effect is f dash equals to f whole bracket v plus minus v o, or we can say v observer, divided by whole bracket b plus minus vs for source. So now f dash in this equation is observed frequency, f is actual frequency, v is velocity of sound, v naught is the velocity of observer, and vs is the velocity of source. Now guys, let's move on to the derivation part. And in order to derive Doppler effect, there are two situations that needed to consider, and they are stationary source and moving observer, and moving source and stationary observer. Now let us consider case 1, that is stationary source and moving observer. In this case, what we have is there is stationary source and the observer is moving towards this source. If observer moves towards the source, then there will be higher frequency. This is due to the crossing of more number of waves through the observer. And if the observer is moving away from the source, then what will happen is there will be lower frequency. This is due to the passing of less number of waves through the observer. So to figure out the actual frequency, let's zoom it. Okay, let us consider these are the two waves and this is the observer. So and let us also consider that observer is moving at constant speed, so the velocity of observer will be v obs, that is v observer, and the time period it takes, it will be t obs, that is t observer. Similarly, the speed of the wave to meet the observer will be vw, v wave, and the time period that observer observed will be the t obs. And we know that the distance between two waves is actually the wavelength, that is lambda. So now let's move to derive lambda. So lambda, we can derive this lambda or wavelength that the source emitted by just simply adding these two distances. So lambda will be equal to vw, v wave, t observer plus v observer, t observer, which is equal to t observer whole bracket v wave plus v observer by taking t observer as common factor. So let's derive this t observer, time period for observer. So it will be equal to lambda by v wave plus v observer. Now since there is another equation for this velocity v wave equals to lambda source by t source, or we can say that vw, v wave, t source will be equal to lambda source. And now we have to find this t observer. So we are finding to find this t observer, it will be equal to vw ts divided by vw plus vobs by substituting the value of this lambda from this equation. And since we have to find actual frequency, or we have to relate frequency in physics, there are more value for this frequency. So to relate this frequency, we know that frequency is the reciprocal of time period. So 1 by t observer will be equal to V wave plus V observer divided by V wave into T source. So this 1 by T observer will be frequency. We are considering F as frequency, so F observer equals to 1 by this Ts whole bracket V Doppler plus V observer divided by V Doppler or V wave. So the frequency of observer will be equal to frequency of source into V wave or velocity of wave plus velocity of observer divided by velocity of wave. And this is for the case when the observer moved towards the source. For the case where observer is moving away from the source, we have frequency of observer equals to frequency of source into this velocity of wave. There will be minus sign. Simply there will be minus sign as in the case for the case when the observer moves away from the source. V observer divided by V Doppler. Now guys, let's consider case 2. So here the case will be moving source and this stationary observer. So I have considered this as observer and this is the moving source. And we know that moving sources have change in wavelength. So let me make you clear about what we are going to use in this deriving this formula. So we are using actual frequency as F, sound speed as V, source speed as Vs, speed of observer as V OVS, actual wavelength as lambda. And we know that lambda is equals to V by F, velocity by frequency. So let it be the equation number 1. And since the source is moving, so there will be change in wavelength. So let us consider that there is change in wavelength. So del lambda will be equal to Vs divided by F. That is where I had already told you that Vs is the source speed and F is the actual frequency. So let us also consider this as equation number 2. Now the change in wavelength to observer is lambda observer equals to lambda minus del lambda, or lambda observer equals to V by F, that is sound speed divided by actual frequency minus source speed divided by actual frequency. So I had substituted this value for this lambda and this for this del lambda from equation number 1 and 2. Now the del observer will be equal to V, that is sound speed minus source speed divided by frequency, actual frequency. But as in case 1, we have to find frequency. Here also we have to find frequency. So frequency of observer will be equal to V by del lambda observer, or it is equal to V by V minus Vs by F, substituting this value for this lambda observer. So the frequency of the observer will be F into V by V minus Vs. This as in case 1, this is when the source is moving towards the observer. But for the case when the source is moving away from the observer, this equation will change as F observer equals to F into V by V plus Vs. Here also we have changed this sign from minus to plus. So till now we have discussed Doppler effect in sound. Now we are going to discuss Doppler effect in light. So the Doppler effect also affects the light which is emitted by other bodies in space, and it is categorized into two shifts, that are red shift and blue shift. So red shift is nothing but when light waves are spread apart and it is traveling away from us, it is said to be red shift. And when light are compacted and it is coming towards us, we call this as blue shift. Now you must have questioned that what causes the red and blue shifts. So for this, let me explain you. Red shift is occurs when the light source is moving away from the source, and since the light source is moving away from the source, there will be lower in frequency, or we can say there will be less frequency received by the observer. So this what will cause this? Now this will shift the light will shift towards the red end of the visible light spectrum and thus causes redshift. Similarly, for the blue shift, there will be light source moving. There will be just opposite. Light source will move towards the observer, and this causes greater number of frequency passing through the observer, and this light shift towards the blue end of the visible light spectrum and causes blue shifts. Now moving on to the application part. So Doppler effect is mostly applicable in sirens, radar, medical imaging, blood flow measurement, audio, and so on. So here we are discussing only about this much. Since everything has its limitation, Doppler effect also has some limitations, like it is applicable only when the velocities of source of sound and the observer are much less than the velocity of sound, and it is applicable when the motion of both the observer and the source is along the same straight line. And if in case of air medium, what will happen is, if the direction of the motion are different, in case when wind is blowing, in that case we need some modifications in formula. Thank you for watching this video. Since this is my first video, hope you guys like it.